know where there's some. Right here in the hall clerk.
No, Molly, not in there. I have
I've rotated the chassis so we can see a bit better inside. And I want to draw your attention to this capacitor right here because all the numbers that we need are very visible. Let me move the camera again. I'll move the radio. And you can reach in. If this hasn't been run for 50 years, it's okay to just reach in there. It's not plugged in. Not plugged in. It's okay to reach in there and touch these and rotate them. Here are the two numbers on every one of these capacitors we're going to try to look for. It's generally going to be a decimal point followed by a number, 0.05 in this case, and then the letters MFD. That stands for microfarad. So this is a 0.05 microfarad capacitor, and you need to write that down. And then the next thing you want to know is this value right here. Somewhere on the capacitor will say VDC or volts, but that's the peak voltage this capacitor can handle. So this capacitor is 400 volts DC. When you replace it, you need to replace it with another capacitor that can handle 400 volts or higher, and you need to replace it with a capacitor that is about 0.05. Now, as it turns out, over time, 0.05 microfarad capacitors are made still, and you can buy them, but they've kind of been replaced by a 0.047 microfarad capacitor for who knows what reason. I certainly don't. But they're so close, 0.047 and 0.05 in this kind of equipment. Doesn't matter. It doesn't matter. If you can't find a 0.05 microfarad capacitor at 400 volts DC, find a 0.047 microfarad capacitor at 400 volts DC. So what you're going to do is you're going to take a piece of paper and write down the values of every one of these waxy paper caps. This one here is 0.02 microfarad at 400 volts DC. This one is another 0.05 at 400 volts DC. Over here, we have reading up, well, let me rotate the cabinet again. The chassis, rather. Over here, we have a 0.01 microfarad capacitor at 600 volts. So this one has a higher voltage rating than that guy. But don't worry, they're readily available at 600 and more volts. This one over here is a little more difficult to read. It does say a 0.02 microfarad at 600 volts. So we'll make note of that. One way to expose lettering, if the wax is turned dark and covered up the lettering, you can scrape it very gently with a knife blade. Scrape the wax away, not scraping the paper underneath, but scrape the wax away and you can see the number. So we've identified 1, 2, 3, 4, 5 of the capacitors we need. Now we have 2 we can't see. There's this one here. We know it's a waxy paper cap just because it looks like one. And this one down here. They're both facing away from us. So what can we do? Well, you can reach down in there with your newly acquired needle nose pliers and move things around a bit. I'm going to move this resistor out of the way so that I can pull this capacitor out and get my hands on it and spin it like that. And now I can see what it is. It is a 0.005 microfarad capacitor at 600 volts DC. 0.005. So we had a 0.05s over here. We have a 0.005 here. That leaves one more, this one right here. It's going to be tough to get to, but I'm going to move this capacitor out of the way. And I'm going to move this big resistor out of the way. Then I'm going to reach in here and see if I can spin that. By the way, you see how this is a bit scorched looking? Let me zoom in a little bit. This is a bit scorched looking. The wax is cracked. This capacitor has been under stress. Anyway, let me see if I can spin this around so we can see what it is. And we can see right here, it's another 0.05 microfarad capacitor. Get another one of these, but it's a 600 volt reading. These were 4. So we need a 0.05 microfarad capacitor at 600 volts for that one. All right, so that takes care of, if you've been making notes, that takes care of all of our waxy paper caps. Now we move on to this one right here. And I'll move the chassis again. These capacitors, generally speaking, these capacitors can be put in either way. They can be put in that way, they can be put in that way. It doesn't matter much, except under some circumstances, but that's beyond the scope of this video and any other I might do on this subject. This one can't. Electrolytics have a couple of characteristics. And let me grab my old bag of old electrolytics here. By the way, everybody who does this hobby has a box or a mountain of old capacitors. I don't know why we keep them. I know smart people probably throw them away, but I'm not that smart. I tend to save things. And I guess one of the reasons, actually, to be honest, is that if you're really going to restore an old radio and you're going to replace this electrolytic with a new modern one, the new modern ones look like they're new and modern. What you can do is take the insides of this out, put that inside, and then put this back together so that from the outside it looks like the original radio. And that's part of the kind of ultra restoration, if you will. But not everybody does that. So back to electrolytic capacitors. Electrolytic capacitors always have a couple of characteristics that let you tell what they are. One is there's a plus symbol on one end. In this case, and the one that's in our radio here, instead of a plus signal, or a plus sign, symbol, there's a word negative. Oh, this one also has the word positive on here. That's because electrolytics are polarized. There's a positive side, there's a negative side. Never shall they be mixed up. Bad things happen. Electrolytics can only work if they're put in the circuit correctly, with the positive going to where the positive leads go and the negative going to wherever the negative leads go. So here are a couple of examples. Here's one. Can't remember what this came out of, but how do I know it's electrolytic? It says plus on one side. It doesn't say anything on the other side, but because it says plus here, I know that this is the positive lead for this electrolytic and this is the negative lead for the electrolytic. Same thing here. Here's a different brand. Again, they have plus signs on the positive side. They have nothing on the negative side, but I know that's negative and I know that's positive because it's marked positive. Any others? Nothing interesting. Modern electrolytic capacitors are marked a little bit differently. Let me get one out of this bag. These electrolytics come in two fashions. They come where both leads come out of one end, like this, or they come, oh, let me grab another electrolytic. Or they come like this, where a lead comes out of each end, as this one does. Now you'll notice on this one, and on the ones I'm going to use, there's nothing that says positive. There are two leads, nothing that says positive. But right here is an arrow pointing that way, and that's kind of a negative symbol. If you look at it that way, that's what it is. It's a negative symbol. That means that's the negative lead. This is the negative lead. This must be the positive lead. Remember on these, or this one, only the positive side was marked, the negative side wasn't marked. These days, modern electrolytics, they only mark the negative side. That's assumption that the positive side is the other lead. Same thing on this one. Again, it's pointing, there is an arrow pointing at one of the leads, in this case, this one, and this is the negative lead, this is the positive lead. But we're not using that capacitor, we're using a couple of these guys, because this is what I had on hand to meet the requirements for this capacitor. So what we do is we do exactly the same thing. What's the microfarad reading for the two capacitors in here? Well, in this case, I'll push this way a little bit, and we can see that there are two values. Here it says red, that's the red lead. It says red, 50 microfarad, 150 volts DC. Down here it says green, 30 microfarad, 150 volts DC, and here's the green lead. So I need two capacitors to replace this one with a rating of 50 microfarads at 150 volts, the other with a rating of 30 microfarads at 150 volts. And that's about what I have. Again, you can be close and not hurt a thing. This one is the one I'm going to replace the 30 microfarad with. It's actually 33. And instead of saying MFD, there's a micro sign and an F on there. I don't know if you can read that. Maybe. And it has its voltage rating right after it, 160 volts. So this called for a 30 at 150 volts. I've got a 33 at 160 volts. It'll work just fine. The other one is 50 at 150 volts. What I've got here is 47 microfarads at 160 volts. Again, that will work just fine. So what you have to pay attention to when we put these in is this negative lead must go down here where the negative symbol is on this existing capacitor, and then the 47 microfarad, taking the place of the 50, will follow the red lead to its end. The 33 microfarad, which is replacing the 30, will work with the green lead and to its end. So those are the electrolytics we're using. Let's see. One other thing I guess it's worth saying, if I haven't said it already, is the waxy paper caps waxy paper caps in here are being replaced by modern capacitors. Modern capacitors no longer say what the value in microfarads is. They say the voltage, this one is 630 volts. But there's this funny code, 472K. It doesn't say anywhere on here how many microfarads this particular capacitor is. Just just 472K. So what you need is you either memorize a table or you get yourself a cheat sheet. Which is what I have right here. You can get these on the internet. I'll put a source for this down below as well. So capacitors have a code. These are modern capacitors. They have a measurement, they have a value in picofarads, in nanofarads, and microfarads. So what we have here is a capacitor that says it's a 472K. We can ignore the K, but that does mean it's a 472. Here's a 471, and a little further down the line, it should be our 472, right there. So here's the 472 code. Right here. 472K, 472. This capacitor's capacitance is rated at 4,700 picofarads, PF, or, all the same number, 4.7 nanofarads, or 0.0047 microfarads. Now remember, in here we have this one that's right here. This guy right here is rated at 0.005 microfarads. This is as close as you can generally get. If you had a 502 capacitor, you could use that. That would be exactly on. What I have is a 472. Its rating is 0.0047 microfarads at 630 volts, replacing a 0.005 at 600 volts. This capacitor will again work just fine. So you have to, when you order the capacitors, you're going to either order them by this code or you're going to order them by the value itself. You just have to be aware that all modern capacitors now have a code on them instead of the straight value. And again, I don't know why. It's just the way it is these days. There's a link down below to one of many capacitor code charts you can download from the internet. Here's one right here. See if I can run this. Yes. And I'll slide this down maybe a bit. No. Yes, it will. There are typically 4 columns. One for capacitance value in picofarads, one for nanofarads, one for microfarads, and then the code itself. For example, we need a 0.005 microfarad capacitor, which is right here, and the code is 502. If we need that 0.05, there is a code for that. This chart doesn't have that, but it does have the 0.047, which is right here. Other charts will have 0.05 for you as well. But a 0.047 is close enough, and that's code 473. So when you go to, actually when you order the capacitors, I'll show you in a second. When you order the capacitors, you can easily see what their microfarad rating is, as well as their voltage rating on the order sheet. But when they arrive, they probably won't say, in this case, 0.047. They will say 473. So you have to have a chart handy so you can translate that back to what microfarad rating is. Let me show you a couple of sites where you can order capacitors. Here's one from a site called TubeRadios.com. This is Sal's Capacitor Corner. Sal sells that kind of stuff. A couple of things to make note of on this site, and I have nothing to do with these sites. I get no consideration, no nothing. I just mention them because I know of them and I've ordered from them in the past. For Sal's Capacitor Corner, there's an order form you have to click down, which is actually a Excel spreadsheet. So you'll need to be able to use an Excel spreadsheet in order to order. But this will give you an idea of what Sal sells. He has a minimum, I think he has a minimum buy too of $15 or something like that. I don't know, check carefully, check the small print before you order. But here are some really common, he stocks these really common axial lead capacitors. Remember the lead coming out both sides, both ends, one lead coming out each end. And these are really common in radios. These are axial film capacitors. You don't need to worry about what a modern capacitor is made of. They're far superior to what the old waxy paper caps were, no matter what they're made of. So if this suits your need, this is what you need. This is what you should buy. Here's our 0.047 at 630 volts. That's plenty of voltage. And Sal sells them for 32 cents each. He also sells electrolytics on this site. Down here somewhere. He sells a lot of different kind of capacitors. Yeah, here are electrolytics. Again, these are axial lead. Here's a, what did we need? A 30, well here's a 33 that would, whoop, that one wouldn't. This one would. This 33 microfarad at 160 volts would work just fine. Sal sells them for 75 cents each. The other one was a 47, that's 85 cents. And they look like this. So Sal has a nice supply of electrolytics of any kind of capacitor you want. But pay attention right here, you have to download the order form, which I'll click on, and then open. And we'll take a look at that. Has macros, and we're looking at just a corner of it here. See if I can drag it into view. Yeah, here's Sal's capacitor corner order sheet. You put if you want to order a 1 each, this 0.047 at 603 volts, you put a 1 right there. But do keep in mind that he has a minimum order of $15 or $18, can't remember which, not including shipping. So you have to order a fair number of capacitors from him. If you do this for a hobby, you order a fair number of capacitors every time you do it. But that's Sal's. Let's look at a different one. Let's look at, let's see. Yeah, Tubes and More is another source of capacitors, and they have a I don't think they have a minimum order. I don't think they do. But what you do is you scroll down here and pick out the capacitance you want. Again, in our case, we wanted a 0.047. So there's a 0.047, you click that, shows you the 0.047s. Now, Antique Radio or Electronic Supply sells both these yellow polyester film capacitors, which I use mostly. They also sell, these are called orange drops, brown drops. They serve the same purpose. They work exactly the same way. Pick what delights you. If you like big blobs of orange inside your radio, go for the big blobs of orange. That's up to you. It doesn't matter. And down at the bottom here, he sells an interesting capacitor. They're very expensive in my book, but These guys sell a capacitor which looks very much like the vintage capacitors. They're modern capacitors, but they're housed in wrappers that make them look vintage. I think, yeah, they say vintage tone on them. So you can order these kind from there as well. So you pick your value. It lists the price of each one. Let's go back up here to something I would order. One of these guys. Pick your value. 0.047. How many do I want? One. Add it to the cart. And it will open a... oh, no. This one doesn't. This one just tells you what's in your shopping cart. Then you can go up here and pick it out. Let's look at a third one. They're all very similar. You know, how many different ways can you sell a capacitor? That's the question. Let's look at this one, old radio parts here. They sell a lot of stuff for old radios, including knobs and controls and things like that. So here's their capacitor sheet. They have Mylar and Electrolytic. The Electrolytics are the ones that we need. There are two of them in that bright yellow can, but the Mylar are replacing all the waxy paper caps, and they'll do that just fine. This place has a minimum $15 purchase on all orders, but they're very easy to order. You just pick your value, whether you want 1 or 25 or 100, and click on it, and it'll add it to your cart. And I think you go straight to PayPal to pay. So those are options for ordering capacitors. So I have my capacitors on hand. I have not ordered any resistors because these all look peachy. There's one right here that doesn't look so peachy, but there's a good reason for it. I'll show it to you. See how this resistor right here is red, red, green? That's its value. That's a 2, 2 followed by 5 zeros. 220,000 ohm resistor right here. Here's a funny looking thing that looks sort of like a resistor. It's kind of a doughboy shape. It has these color codes on it, very much like our resistor. It has silver painted on the end of it, though. And those are kind of the giveaways. Its shape and the fact that it has silver on the end of it says this is a capacitor. There are varieties of capacitors that almost never need to be changed. And this is one right here. This is a Mica capacitor, I think. I should look that up. Let me talk a little bit more about capacitors. I'll shut this off and we'll talk about capacitors for a minute. I'll start back up and we'll talk about capacitors. Yes, that was correct. I just looked it up on the parts list. This is indeed a Mica capacitor with a value of, where did it go? I'm looking at the parts list. 330 picofarads. So this is a very small value capacitor. It's Mica. Mica capacitors in this kind of implementation almost never fail. They'll last for hundreds of years as far as anybody can tell. There's another kind of capacitor that is equally stable and long-lasting. I'll try to show you one of those. Okay, this guy is a ceramic disc capacitor, and they've been making them for a long time. They certainly made ceramic disc capacitors when this radio was constructed. They will, in the vintage radios, they will be brown in color, and they'll have some numbers on them. But these guys, they're made out of ceramic, and like the Mica ones, they last forever. They're very temperature stable is one of the reasons they use them for a lot of signal passing stuff. But you'll see this shape, flat disc, this shape, but brown in a lot of vintage radios. And these guys almost never have to be replaced unless they're obviously broken. and they can be broken by jerking too hard on the leads, so on and so forth, but very, very, very rarely. So if you see one of these in your radio, you know you have a capacitor. You also know you probably don't have to worry about it in the slightest, because it's going to work right out of the chute. Okay, by the way, I have in my schedule to do a video on capacitors, how they work, and what they look like in their various guises, particularly in vintage radios. So that will be coming up fairly shortly if you want more information on capacitors. But for right now, I think in terms of our repair of this GE107, I think that's all we need to know. I think we're ready to start replacing parts, which we'll do in the very next video. But that's it for this one. Take care. See you next time.